and good morning to everyone, especially to our session chair, as well as everyone, fellow presenters. Um, my name is Azir Rezha Norizan. Well, for today, I'm going to present my paper entitled UTAUT2 to analyze the factor influencing the use of virtual reality head-mounted display or VRHMD device. So, looking at the background of my study, uh, arguably one of the effects from the pandemics is most community actually increasing their time spent with IT or technology products. And the same goes to VR headset, where a few of the population actually try to purchase VR HMD device to experience themselves on the virtual reality side. A previous study have explained that lots of potential use for HMD technology for industry sectors such as education, engineering, as well as simulation. And the availability of VR head-mounted display with various categories in the market, further adding to the level of virtual reality user experience nowadays. And this study mainly to examine the factor that drive the use of VR headset. So we use UTAUT or Unified Theory of Acceptance and the Use of Technology 2. And this being formulated by Venkatesh et al. He suggested that seven main factors influence the purpose and the use of technology. So in 2003, UTAUT, the first model being invented, where they have four main factors that influence the purpose of use of information technology. The first one is performance expectancy, where you actually define how the level of belief of a certain system or technology will help to improve performance. Second one is the effort expectancy is quite similar to performance expectancy, where you expect or believe that system of technology will somehow increase the level of ease of use of certain system. Facilitating condition define the level of individual belief that there is a technical or organizational infrastructure that supports the use of the system or technology. For in our case, like VR headset or HMD devices, where we believe part of the facilitating condition, including a very fast internet speed connection. And looking back to the social influence there, the fourth criteria or construct. Social influence refer to how uh, a person feels that he or she should use or purchase a certain system or technology because as a result of influence by others or society. So this model being enhanced by Venkatesh and his groups in 2012, where he added three more constructs. The first one is hedonic motivation, where hedonic motivation refer to the level of individual enjoyment in using particular technology. Price value, where the cost and the price structure may have significant impacts on the use of technology itself. And habit here is referring to the individual experience of technology. So here in this study, we added two more independent variables to make that our model called extended UTAUT2 model. We add personal innovativeness, where personal innovativeness actually referring to the level of readiness of the individuals in trying new technologies. And this is because we assume that individuals with high innovative attitudes or thinking are more likely or easily to adapt to the technology. And perceived risk is about uh, the knowledge of risk that may be encountered in the use of the new technology, such as mental health or maybe any kind of physical adjacents, accidents, and privacy-related risks. So the methodology used in this study, first, we use PLS SEM to enable or to estimate complex models with many constructs. Because in our study, we have at least 9 plus 2, 11 constructs where we're going to try to emulate the relationship between each constructs. And PLS SEM broadly used in estimation of technology acceptance model. This is because the same method being used in TAM, and TAM is somehow what we call older version of UTAUT, where TAM being construct first the initial model of UTAUT. So in this study, 3 steps were used when applying PLS SEM. The first one is validity testing and reliability testing of the developed questionnaire. Second one is hypothesis testing, and the third, modeling new construct for hypothesis testing. So we use Smart PLS 3.3, to test measurement model and structural model. And we use a rule of thumb with a ratio of 10 to 1 to construct, to actually choose 360 respondents, because we have 36 items that being used to measure 11 constructs in the model. And we use Likert scale to evaluate the data from our respondents. So this is the data. First, we do the measurement model analysis. Looking at the convergent validity, where it's actually met when outer loadings or loadings date value here of each indicator or items is at least 0.7. So by looking at this table, we found that 3 questions or items, and in this case, PE3 or P3 referring to performance expectancy, question number 3. FC4 with facilitating condition, question number 4, and PV3, which is price value, question number 3, has value lesser than 0.7. So these indicators will remove to make the convergent validity. Next, we read the average variance extracted AVE. Measure convergent validity of latent constructs. A value greater than 0.5 is acceptable. So we focus on the AVE value here, where from the data we can see that price value have value lesser than 0.5. Therefore, it is not acceptable. And for reliability testing, composite reliability or CR value should be at least 0.6. So by looking at the whole data on the table, all variables seem to have data over 0.6. So every variables here should be accepted. But then we look at the Cronbach alpha value, where the average measure of internal consistency and measured reliability value should be greater than 0.7, and it should be acceptable. So again, price value has Cronbach alpha value lesser than 0.7. Therefore, price value being removed from the main variable models. Okay, now we look at the structural model analysis. So now, instead of looking at the individual question, we look at the variable and the relationship as a whole. So path coefficients value that is adjacent to +1, okay, +1 portray significant relationship, while value adjacent to -1 portray the other way, which is not acceptable or insignificant relationship. So looking at the table, we found that 2 data there, EE, which is effort expectancy, is somehow not really significant, affecting or influencing the behavioral intention because it has negative value there. The same goes to facilitating condition, where somehow it's not directly influencing user behavior because of the negative value. Next, the study used the significance level of 5%, so the p-value should be less than 0.05. Now, looking to the p-value there in the table, we found that only 5 items or 5 variables or constructs has a value that less than 0.05. Okay, this defines the significance of the relationship. And another thing, we look at the uh, T statistics because we want to determine which relationship of latent variables is significant. The value should be larger than 1.96. And again, here you can see that the same variables, which is hedonic motivation influencing behavioral intention, the same goes to habit and personal innovativeness are directly influencing or significantly influencing the behavioral intention. And down there, we can see that behavioral intention or BI influencing directly to user behavior. And HT or habit also significantly influencing user behavior. Therefore, briefing of this data, we found that the 5 relationships are accepted and the rest were rejected. So as a conclusion, the main objective of this study is to analyze the factor influencing the use of the virtual reality head-mounted display device. And based on enhanced UT-AUT model that we use, hedonic motivation, habit, and personal innovativeness positively influence user behavioral intention in using the VR HMD device. And habit and the behavioral intention significantly influence user use behavior. So that is our conclusion for my paper. Thank you very much. And any question can be asked through my email. Thank you.